Hello everyone and welcome to Say It with Symbols 4.3. This will be on page 69 of your textbook, and the aces that go along with 4.3 are 14 through 20 and 42 through 48, just the even ones. So on page 69, we're here with generating patterns, linear, exponential, and quadratic. And what's going to happen in this one is we're kind of wrapping everything up that we've gone through, not just in this book, but kind of just about everything we've gone through so far this year with our equations. We're going to give you two data points, okay, for linear, exponential, and quadratic relationship. And we'll use these points to find more data points based off the rules that we've been using for different types of equations. And then once you've filled out the table, you're going to write an equation for each relationship. It asks you here, is it always possible to find a linear, exponential, or quadratic equation from two given points? Meaning, no matter where those 2 points are, can we find one of these at least, maybe all of them? So pause the video, think about that for a second, and determine if you can find those or not. And then in some cases, can you find more than one equation? And you may find that out today. So in the problem, part A, it says the first two rows in a table of numbers are given below. So here we are, we have 1 in the first, 2 for x in the second, with 4 going across for each of linear, exponential, and quadratic. It says write 4 more numbers in each column to make a linear relationship here, an exponential relationship here, and then a quadratic relationship here. Remember that with our linear relationships that we always have to have a constant rate of change. Okay, constant rate of change, that's what we've been working on since thinking with mathematical models. Okay, and then for our exponential relationship, there has to be a constant growth factor. Okay, which is what we learned about in growing, growing, growing. And finally, in our quadratic relationship, we could have many patterns that you could generate for this one. What's important with our quadratic relationships is that our second differences must have a constant non-zero rate of change. Okay, so that's the important part about the quadratic, is that the second differences must have a constant non-zero rate of change. Once you have the table filled out, explain why the pattern in each column is correct, write an equation for each relationship, and explain what each of your numbers and variables mean, as in slope or growth factor or exponent or whatever it is. Okay, explain what the information is for the variables and the numbers. And then compare your equations with the rest of your teammates, maybe the rest of your class. Did you all come up with the same equations, or did some of you have different equations? So that's it for 4.3, kind of culminating here with coming up with equations of different types, linear, exponential, and quadratic, that we've been working on all year. Again, the ACES questions 14 through 20, and then 42 through 48, just the even ones. Good luck. Look forward to your questions and comments in class.